So we continue again with example 6. It's still chapter 3. The method of to control is induction motor. Okay, so in example 6, okay, the method used is controlling supply voltage. Okay, so previously on example 3 and 4, what we have done is we control the speed by added resistance in series with rotor resistor. Okay, so for this example 6, okay, we control the motor by controlling supply voltage. Okay, so you can read the question first. Okay, so okay, 3-phase star connected 4 poles for 50 Hz for 1.5 volt. Okay, so remember this is star connected system, so the given voltage here is V line. So we know that for star, V phase is not equal to V line. So you have to pay attention at the voltage supply. Okay, as long as the connection. Okay, if star is if data, the voltage will be similar. And then this is the parameters or resistance that referred to stator side. Okay, so usually on this example, okay, and in this problem regarding controlling supply voltage, okay, we will analyze this equation, okay, during normal and required condition. Okay, so during normal condition, okay, so in this part, the question asks to determine all these parameter during normal or rated condition. Okay, so the first one is NS. Okay, so NS is 120 F over P. Okay, so NS is not okay, 120 F, 50 over P is 4. So the answer is 1500 RPM. Okay, and then for the angle speed omega s, which is we want to convert the synchronous speed into in term of RPM to radian per second. So 2 pi over 60 multiplied by ns. Okay, so we get 157.08 radian per second. And then S, we can determine S equals to NS minus NR over NS. Okay, during rated speed, okay, given the rated speed is 1200 RPM. Okay, it mentioned in the equation. So you can determine S, so 0.2. Right, so if you notice here, and the equation also given the fan load torque, so TL equals to K, okay, multiplied by 1 minus S squared. So in this case, you have to determine K. So how to determine K? So by using torque equation. So this K we going to use on this second question, part B. Right, so T rated, the formula is 3V phase squared over S1 omega S. Okay, R prime 2 over R1 plus R prime 2 over S1, okay, squared plus S1 plus X2 squared. Okay, I hope you can remember this equation. Okay, so based on calculation, okay, the rated torque is 33.06 Newton meter. Okay, so from this torque we can determine K. So K is, okay, TL is 33, which is, this is T rated, T rated 33.06 over 1 minus S. So S is 0.2, still on during normal condition. So K is 51.66. Okay, so this K we will use in part B. Okay, because of that one is the constant, the K is the constant. Okay, so on part B, okay, the question asks to, okay, by using the approximated equivalent circuit with a slip of 0.4. Okay, So given slip is S 0.4. Okay, the first question is the speed of the motor, okay, during S 0.4. So we can determine NS is similar 1500. Okay, 1500 1 minus S is 0.4. This is S2 so I name this as a S2. Okay, 0.4. So we can get the NR2 is 900 rpm. So this is okay, the rotor speed, okay, during S slip 2 equals to 0.4. So next one, okay, the motor torque. Okay, we can determine the motor torque, okay, by using T equals to 3 V phase. Okay, sorry, T2, okay, we can determine by using this equation, TL K1 minus S squared. Okay, because of we already have the value of K. So K is 51.66. Okay, multiply by 1 minus S2. This is S2 0.4. Okay, squared. So you can get the answer T2 is 18.6 Newton meter. Okay, so this is the answer for motor torque during S 0.4. Okay, by using TL. Okay, this one TL equals to K 1 minus S. So we get from the previous section A. Right, so number 3. Okay, so this is number 2. So number 3, we want to determine the motor terminal voltage. Okay, of course by using equation of torque. Okay, T2 equals to 3 V phase squared over S2 omega S. Okay, R prime 2 over R1 plus R prime 2 over S2 squared plus X1 plus X2. Okay, so the difference here is S2 and this one S2. So what we want to determine is this voltage, this supply voltage, because of this method is controlling supply voltage. So we want to know what is the value of V supply when the speed is 900 rpm. Okay, so you can instead of the all these value. Okay, what I get here is okay, 155. Okay, from this equation, okay, V single phase is 155 147. Okay, so remember this is star connected system. So the answer should be in term of line. So we know that V line equals to square root of 3 V phase. Okay, in term of magnitude, the answer is 269.3 volt. Okay, so this is okay, the answer for number 3, the motor terminal voltage. Okay, and lastly the stator current. Okay, the stator current, you can use the formula I. Okay, I stator equals to Im plus R prime 2. Okay, so Im is V single phase over JXM, and then I prime 2 is V single phase, okay, over R1 plus R prime 2 S2, okay, plus J, okay, plus J X1 plus X2. Okay, so you can determine Im and I prime 2. So what I get here, Im is negative J 1.94 ampere, and then I prime 2 is 7.27 minus J 5.01 ampere, and then lastly DIS summation Im plus I prime 2. So you can get 10.06 angle of negative 43.7 ampere. Okay, so we continue on example 9. Okay, still the similar method, which is controlling supply voltage. Okay, so okay, you can read the question. Okay, so I straightforward to how to determine okay, the equation. Okay, so given here, okay, delta connected system, okay, delta connected system 415 volt. So we know that V line for delta is equal to V phase. So V line is equal to V phase, and then the rated speed is 925 RPM. Okay, so and then this is the parameter that refer to stator. Okay, so the number of poles is 6. Okay, so firstly we can determine, okay, we can determine NS and omega S. Okay, this is the parameter that we usually determine first. Okay, 120F over P. So P is 6, so NS is 1000 RPM. And then we can determine omega S. Okay, 2 pi NS, okay, over 60 is equal to 104.72, okay, radian per second. Okay, so in this question, okay, the motor drive a fan load having a torque characteristic of T equals to 0.45 omega. The speed omega is expressed in radian per second. Okay, so the first question A, the motor, okay, determine the motor terminal voltage, current and torque at 750 RPM. So at 750 RPM, okay, the first parameter that we can determine is S. Okay, S equals to NS minus NR. So this is NR. This is the value of NR, 750 RPM over NS. Okay, this is 1000. Remember, NS is not changed, okay, throughout this condition. Okay, so S is 0.25. Okay, so from okay, and then one more thing, this omega is not omega S, this is omega R. So omega R that we express in radian per second. So you have to determine omega R, which is equals to 2 pi NR. Instead of NS, we use NR, 750 divided by 60, which is 78.54, okay, radian per second. Okay, and then for the first question, we can determine torque T. Okay, 0.45 multiplied by omega R. So omega R is 78.54. So you can calculate the torque is 35.34 Newton meter. And then okay, so from this torque, okay, the next question we can determine is terminal voltage. So T equals to 3 V phase square S 0.25. Okay, omega S is not changed, 0.104.72. So that's why we determine, okay, omega S. Okay, and then this is R prime 2 over R1 plus R prime 2 over, okay, S 0.25, okay, squared plus x1 plus x2 squared. Okay, so okay, from this equation we can determine V phase. Okay, so the answer is V phase equals to 66,113 volt. Okay, because of this is delta connected system, which is V phase equals to V line, right? Okay, so this one you can use calculator to determine the value. Okay, so next one is current. Okay, so torque we have done, and then next one is current I. So I equals to V phase divided by R1 plus R prime 2 over S plus J x1 plus x2. So actually you can separate, either you determine IM and then plus with IR, okay, ataupun boleh buat semua sekali lah. Okay, right, so the answer for I, okay, 27.77 angle of 39.04. Okay, and then you have to remember this is the delta connected system. So I line equals to square root of 3 I face. Okay, in term of magnitude. So we have to determine I line. So I line is equals to 48.1. Okay, angle of negative 39.04. Okay, so angle is not you just take this one, this angle. So actually the correct way is you have to minus by 30 kan. So theta minus by 30 degree, then you can get the real answer. Okay,